March 1942, Dayton, Ohio. Inside the headquarters of the National Cash Register Company, Joseph Desch, a quiet civilian engineer, faced a group of grim-faced U.S. Navy commanders. The British were blind, their codebreakers defeated by the German Navy's new four-rotor Shark Enigma, and U-boats were winning the war. The mission they offered Desch was staggering: design and build from scratch a machine to do the impossible, a top-secret task on par with the Manhattan Project. This is the story of how one civilian's impossible machine cracked Hitler's unbreakable code. In the middle of the Atlantic lay the Black Pit, a desolate stretch of water beyond the range of Allied air cover, where German U-boats, the sleek predators of the Kriegsmarine, reigned supreme. Here, death could come at any moment, announced by the faint hiss of a torpedo trail followed by a cataclysmic eruption of water and steel. The architects of this terror were the Wolf Packs, conceived by the brilliant and ruthless commander of the U-boat arm, Admiral Karl Donitz. The strategy was brutally effective. Instead of single submarines hunting alone, U-boats would spread out in long patrol lines across convoy routes. When one spotted a target, it would not attack immediately, but would shadow the convoy, radioing its position back to headquarters. Donitz, from his command center in France, would then gather a pack of 6, 10, or even 20 submarines to converge on the target for a coordinated nighttime surface attack. Their success was built on a foundation of absolute secrecy, guaranteed by a machine the Germans believed to be infallible: the Enigma. The Enigma was a masterpiece of cryptographic complexity. When a German operator pressed a key, an electrical current would pass through a maze of wiring designed to create a completely different output letter. The first layer of scrambling came from the plugboard, or steckerbrett, at the front of the machine. This looked like an old telephone switchboard, where operators could use cables to swap pairs of letters before the signal even entered the core of the machine. With 10 cables in use, this single component added over 150 trillion possible variations to the setup. From the plugboard, the signal traveled into the heart of the machine, a set of rotating wheels, or rotors. Each rotor was a hockey puck-sized disc with 26 electrical contacts on each face, internally wired to scramble the signal that passed through it. With every key press, the rightmost rotor would click forward one position, like the odometer in a car. After a full rotation, it would kick the middle rotor forward, which in turn would eventually kick the leftmost rotor. This constant movement ensured that even if an operator typed "ah," the encrypted output would be 5 different random-looking letters. Finally, the signal hit a unique component called the reflector, which sent the current back through the rotors by a different path, ensuring a letter could never be encrypted as itself, a feature that was both a security measure and, unbeknownst to the Germans, a fatal cryptographic flaw. The German Army and Air Force used a 3-rotor Enigma. The number of possible starting positions was already astronomical, reaching 159 quintillion. For years, the brilliant minds at Britain's Bletchley Park, led by figures like Alan Turing, had managed to stay one step ahead, cracking the code using a combination of captured codebooks, mathematical genius, and their own electromechanical device called the bomb. But the German Navy, the Kriegsmarine, was always more security conscious. In February of 1942, they introduced a new Enigma model for their U-boat fleet, codenamed Shark. This M4 Enigma had a 4th, slim rotor tucked into the front of the machine. The addition of this single wheel didn't just add complexity, it multiplied it exponentially. The number of possible daily settings skyrocketed to a figure so large it defies easy comprehension, a 1 followed by 145 zeros, a number greater than the estimated number of atoms in the entire observable universe. For the codebreakers at Bletchley Park, the Shark blackout was a catastrophe. Their bommies, designed for the 3-rotor problem, were suddenly obsolete. The intelligence tap that had been their most crucial weapon was shut off. Decryption went from taking hours to taking weeks, if it was possible at all. The results were immediate and devastating. U-boat command could now orchestrate their Wolfpack attacks with impunity. The tonnage of sunken Allied ships soared. In 1942, alone, U-boats sank over 1,600 Allied ships, sending more than 8 million tons of critical supplies to the bottom of the ocean. Great Britain was on the verge of being starved into submission. The entire Allied war effort was at risk of collapse. The problem seemed impossible. The Allies needed a new weapon, a faster, more powerful machine. Desperate, the United States Navy began a secret search, not for a general, but for an engineer. Their search led them to an unexpected place, a cash register factory in Dayton, Ohio. The Navy needed a miracle, and they were about to ask a civilian to build it. The man the U.S. Navy turned to was Joseph Raymond Desch. He was not a military strategist or a seasoned cryptographer. He was the head of the Electrical Research Laboratory at the National Cash Register Company, or NCR. Born in Dayton, Ohio, in 1907, Desch was a product of the American heartland, quiet, methodical, and possessing a mind that saw the world in circuits and vacuum tubes. His fascination with electronics was innate. As a boy, he built his own crystal radio set at just 11 years old, scavenging parts and teaching himself radio theory from library books. This passion led him to the University of Dayton, where his thesis on vacuum tube circuits placed him at the cutting edge of electronic theory. In 1938, he was recruited by NCR. While the company was famous for its intricate mechanical cash registers, marvels of gears and levers, its visionary leader, Colonel Edward Deeds, saw that the future was electronic. Deeds had fostered a unique culture of innovation at NCR, creating a space where brilliant engineers were given the resources and freedom to pursue radical new ideas. Desch was hired to lead that charge. He quickly proved his worth. By 1939, he and his colleague, Robert Mumma, had developed the world's first electronic calculator, a room-sized machine that used over 500 vacuum tubes to perform calculations at speeds no mechanical device could dream of matching. More importantly, for the coming war, Desch had invented and patented a series of miniature gas-filled tubes called therotrons. These tubes could switch electrical signals on and off millions of times per second, acting as high-speed electronic counters. They were the building blocks of early computing, and they were far more reliable and rugged than anything that had come before. This specific expertise is what landed on the Navy's radar. The Navy's Signals Intelligence Arm, OP-20G, knew they couldn't simply copy the British bomb. They needed something faster, more powerful, and suitable for industrial-scale production. They needed an engineering wizard who could take the British concept and transform it. After a discreet search of America's top technology firms, the trail led to Dayton. In March 1942, Navy commanders met with Desch. The mission they laid out was staggering: design and build from scratch a new machine to crack the four-rotor Enigma and do it with impossible speed. The project was given the highest priority, on par with the atomic bomb's Manhattan Project. NCR's Building 26, a former employee night school, was commandeered and transformed into the U.S. Naval Computing Machine Laboratory. The facility became a fortress, surrounded by barbed wire, with armed guards patrolling its perimeter 24 hours a day. Desch was made research director, thrust from the world of commercial electronics into the high-stakes pressure of military intelligence. The personal toll was immense. Desch's mother was a German immigrant, and his family name immediately raised red flags for the FBI. He was placed under constant surveillance, his mail opened, and his loyalties questioned. To protect the project's secrecy and prove his dedication, he was forced to make a painful sacrifice. He cut off all contact with his German relatives for the duration of the war. He lived and breathed the project, working punishing hours under a veil of total secrecy. He assembled a small core team of NCR's best engineers, but the bulk of the workforce would come from an even more unlikely source. The Navy recruited 600 members of the WAVES, Women Accepted for Volunteer Emergency Service. These were not factory workers. They were bright young women, many freshly recruited from colleges, with backgrounds in math, science, and engineering. They were brought to Dayton and put to work on the painstaking assembly of the machines. They worked in 3 shifts around the clock, soldering thousands of connections, completely unaware of the true purpose of the strange devices they were building. They were told they were making top-secret radios. The skepticism in the military establishment was palpable. Could a civilian from a cash register company, leading a team of women who didn't even know what they were building, really create a machine to defeat Hitler's greatest secret? Desch's team was now assembled, but building his impossible machine would push them all to their limits. Joseph Desch's creation, the American bomb, was an industrial titan. It stood 7 feet tall, 10 feet long, and 2 feet wide, a monolith of black crackle-painted steel. Each unit weighed over 5,000 pounds, 2.5 tons of wires, relays, gears, and glowing vacuum tubes. To stand in front of one was to face a wall of incomprehensible complexity. Its face was dominated by 16 sets of 4 large, color-coded plugs, corresponding to the 26 letters of the alphabet. Behind this interface lay the machine's heart, 16 sets of 4 massive drums, or commutators, each meticulously wired to perfectly replicate the internal scrambling of a German Enigma rotor. In total, 64 commutators whirred within the machine's guts, each requiring 104 hand-soldered contacts. That meant every single bomb contained over 6,600 precision connections, with miles of wire snaking through its chassis. The story of how this machine was built is a narrative of relentless innovation and brutal trial and error. Desch's initial vision was for a fully electronic bomb, a machine that would use tens of thousands of his vacuum tubes to run its checks at the speed of light. But the engineering reality was that the sheer number of tubes would generate an impossible amount of heat, enough to literally melt the machine and the building around it. So he pivoted to a hybrid design, a brilliant fusion of the mechanical and the electronic. The heavy lifting of simulating the thousands of Enigma rotor positions was done mechanically. The drums spun at an incredible 1,725 revolutions per minute, clicking through potential settings with a deafening industrial clatter. But the brain, the part that checked for logical contradictions based on the cryptographic weakness of the Enigma's reflector, was purely electronic. This is where Desch's Therotron tubes became the secret weapon. They acted as a high-speed electronic memory, pulsing millions of times a second. The bomb worked by exploiting a crib, a snippet of guessed plaintext within an encrypted message. If the Allies suspected a message contained the German word for weather, W-E-T-T-E-R, the operators would program this relationship into the bomb. The machine would then race through every possible rotor setting, testing each one. For each setting, it would check if the crib held true. If it found a contradiction, for instance, if the setting required the letter T to be encrypted as F, but in another part of the crib, the same setting required T to be encrypted as G, it would discard that setting and move on. When it found a setting with no contradictions, a potential correct answer, the magic happened. The current flowing through the Therotron memory circuit would trigger a relay, instantly halting the massive spinning drums. A light on the control panel would illuminate, indicating a hit. The manufacturing process was an epic undertaking, a testament to American industrial might. The 600 waves worked tirelessly in the sweltering, non-air-conditioned heat of Building 26. Each woman was responsible for a specific, repetitive part of the assembly, yet their precision was paramount. The project was not without its crises. Early prototypes were plagued with problems. In one disastrous test, a set of gears ground themselves to pieces under the immense torque of the motors. At another point, a wiring flaw caused a short circuit that nearly started a fire. In late 1942, a Navy inspection team, unimpressed with the slow progress and constant failures, nearly canceled the entire project. But Desch, with his quiet confidence and meticulous engineering data, managed to prove that his design was sound and that rival proposals were unworkable. His leadership was further validated by a secret visitor. In December of 1942, Alan Turing himself traveled from Bletchley Park to Dayton. He and Desch spent days locked in intense technical debates. comparing the British and American designs. Turing was initially skeptical of Desch's start-stop mechanism, but he left deeply impressed by the machine's speed and reliability. Desch wasn't just building a lab prototype, he was building a factory of decryption. By June 1943, the first operational bomb was delivered to the U.S. Navy's secret code-breaking facility on Nebraska Avenue in Washington, D.C. A steady stream of the 2-ton machines soon followed. The machines were ready. The secret army of operators stood by. Now came the ultimate test. The arrival of Joseph Desch's bombs in Washington, D.C. was like the turning of a key in a lock that had held the fate of the war. The impact was immediate and profound. The intelligence flowing from the Allied code-breaking effort was codenamed Ultra. And with the bombs running, the tap of information became a torrent. The process was a race against the clock. Intercepted German naval messages, plucked from the airwaves by listening stations, were rushed to the facility on Nebraska Avenue. There, a team of cryptanalysts would analyze the encrypted text, looking for German procedural quirks or stereotyped phrases that could serve as a crib. Once a promising crib was identified, it was handed over to the bomb operators, another group of highly skilled waves. They would translate the crib into a series of plugboard connections on the face of the machine, set the rotors to a starting position, and throw the switch. The machine would roar to life, its internal relays clattering like 1,000 typewriters as it churned through thousands of potential Enigma settings per minute. The moment a hit occurred and the machine stopped, the operator would run a check on a captured German Enigma machine to confirm the settings. If they were correct, the payoff was immense. Every U-boat message sent on that day, anywhere in the world, was now an open book. The results were breathtaking. Allied intelligence could now see the entire German U-boat strategy laid bare. They knew where the Wolfpack patrol lines were being set up, which convoys were being targeted, and where each U-boat was being ordered to go. The tables had turned. Instead of sailing blindly into ambushes, Allied convoys could now be expertly rerouted around the waiting submarines. More than that, Allied hunter-destroyer groups, equipped with new radar and depth charges, could be sent directly to the U-boats' locations. The hunters had become the hunted. One of the most dramatic successes of ultra-intelligence was the capture of the submarine U-505 in 1944. A decrypted message revealed the submarine's patrol area, allowing a hunter-killer group to corner it. The German crew abandoned the U-boat without properly scuttling it, and an American boarding party managed to get aboard, capturing the submarine intact, along with its Enigma machine and a trove of current codebooks. The ultimate turning point came in May of 1943, a month that would go down in German naval history as Black May. Armed with a continuous flow of ultra-intelligence from the American bombs, Allied forces inflicted devastating losses on the U-boat fleet. In that single month, 41 German submarines were sent to the bottom of the Atlantic, a catastrophic loss rate. Admiral Dönitz was horrified and baffled. He knew his communications must have been compromised, but he refused to believe the Enigma itself was broken. He launched internal investigations, searching for spies and traitors. He blamed faulty German torpedoes and new Allied radar technology. He never suspected that the Allies were reading his every command, often just hours after he issued them. In a state of shock, he withdrew nearly all U-boats from the North Atlantic. The Wolfpack menace was broken. The supply lines to Britain were secured, ensuring the massive buildup of troops and material for the D-Day invasion could proceed. Military historians now widely agree that this intelligence revolution shortened the war by at least 2 years. The American bombs, designed by a civilian and built by women who thought they were making radios, had played a decisive role in that victory. The war ended, but the secrecy around Project Ultra and the Dayton bomb had only just begun. In the final analysis, the story of Joseph Desch and the American bomb is as much about the profound, suffocating weight of secrecy as it is about the soaring heights of ingenuity. When victory in Europe was declared, a strange quiet descended. The frantic percussive clatter of ticker tapes that had been the heartbeat of the war effort ceased. The war rooms, once electric with tension and purpose, fell silent. But as one monumental task ended, another, more insidious one began: the systematic and deliberate erasure of history. By the highest, most inviolable order of the United States government, the entire Naval Computing Machine Laboratory project was to be wiped from the ledger of existence. The directive was absolute, its execution chillingly thorough. The 120 bombs, each a 2.5-ton monolith of brass, steel, and wire, a testament to American intellect and industrial might, were not to be mothballed for a future conflict or enshrined in a museum as artifacts of a hard-won victory. They were to be murdered. Workmen with sledgehammers and cutting torches were brought into the sanctum of Building 26 in Dayton, Ohio, and ordered to dismantle the very machines that had helped turn the tide of the war. These mechanical titans, which had hummed with the sound of 1,000 calculations per second, were reduced to heaps of scrap metal, their intricate guts ripped out and sold for pennies on the pound. The destruction was not limited to the physical. The intellectual architecture of the project was to be immolated. Blueprints that detailed every complex circuit and relay were gathered and consigned to the flames of industrial furnaces, their ashes scattered to the Ohio winds. Operational logs meticulously kept records of every U-boat convoy tracked and every Enigma key broken were shredded into confetti and then pulped. All remaining records of the project's existence were sealed in lead-lined boxes and interred in the deepest, most inaccessible vaults of government archives, destined to gather dust for half a century. Then came the human element, the thousands of people who had breathed life into this secret world, from the visionary Joseph Desch himself to the 600 waves whose nimble fingers had soldered millions of connections, and the dedicated operators who had run the machines around the clock, were gathered for a final, stark debriefing. In rooms filled with the ghosts of their shared, frantic effort, stern-faced officers from naval intelligence laid out the new reality. They were sworn to a lifetime of absolute, unbreachable silence. They took a national security oath that was not a mere formality. It was a sacred covenant, a vow that forbade them from ever speaking about their wartime work. They could not tell their spouses who wondered where they went for 12 hours a day. They could not tell their parents who worried for their safety. They could not, even on their deathbeds, tell their own children what they had done to help save the world. The story of Building 26 was to become a ghost, a memory that existed only in the collective, silent consciousness of those who had lived it. The core reason for this intense, almost fanatical secrecy was rooted not in the war that had just ended, but in the new, colder war that was already beginning to cast its long shadow across the globe. The United States and Great Britain, having cracked the German Enigma and Japanese purple codes, possessed an intelligence advantage of almost unimaginable power. They knew the secret to breaking rotor-based cipher machines, and they understood that this knowledge was a weapon far more potent than any single bomb or battalion. The decision was made to preserve this weapon at all costs. They wanted to ensure that other nations, particularly the emerging post-colonial governments in Africa, Asia, and South America, would continue to use and trust these types of machines, believing them to be the pinnacle of secure communication. In a move of stunningly cynical but strategically brilliant statecraft, the Allies went a step further. They actively sold surplus, refurbished Enigma-like machines to dozens of these fledgling countries. For decades following World War II, governments from Iran to Argentina conducted their most sensitive diplomatic, military, and economic correspondence on machines whose secrets were already held by the listening posts of the NSA and GCHQ. The Allied intelligence agencies could read their secret communications as easily as a morning newspaper. The price of this enduring strategic dominance, this decades-long upper hand in the great game of global espionage, was the lifelong silence of the men and women from Dayton, Ohio. Their stories, their pride, their very history were the currency used to purchase this advantage. Joseph Desch, the quiet genius at the heart of it all, returned to his life at the National Cash Register Company. The door to Building 26 closed behind him, and he locked it in his mind, throwing away the key. He never spoke of it again. He meticulously packed away the memories of those frantic, sleep-deprived years. The immense pressure from the Navy, the dizzying intellectual challenge, the bone-deep satisfaction of seeing his creation come to life and hearing the first clicks of a successfully decoded message. In 1947, a package arrived. Inside was the Medal for Merit, the highest honor a civilian could receive from the United States government. The accompanying citation was a masterpiece of deliberate vagueness, a public lie by omission, praising his exceptional contribution to the war effort without offering a single specific detail. He went on to have a distinguished and celebrated public career, becoming a pioneering figure in the nascent world of digital computing. He led the team that developed the world's first all-transistor commercial computer in 1959, an achievement that would have been the capstone of any other engineer's life. He secured numerous patents and was revered within NCR as a brilliant, methodical, and deeply private corporate engineer. No one in the hallways of his company, no one in his neighborhood, no one in his own family knew that this quiet man was also one of the most important, unheralded heroes of the Second World War. He retired in 1972 and passed away in 1987, taking his incredible, world-altering secret with him to the grave. The silence held for nearly 50 years. It was not until the mid-1990s, when the Cold War had ended and the strategic imperative for secrecy had finally faded, that the U.S. government began the slow process of declassifying the documents related to Project Ultra. A locked door, deep within the National Archives, began to creak open. The story did not emerge in a flood, but in a trickle of redacted reports and newly available files. It was in this slow thaw of information that Joseph Desch's own daughter, Deborah, finally learned the true nature of her father's monumental achievement. She discovered the secret her father had carried not from him, but by reading about it in books published years after his passing, books by historians like Colin Burke and Jim DeBross, who had become historical detectives, painstakingly piecing together the truth. One might wonder, how does such a massive secret, involving thousands of people and a factory of 2-ton machines, stay hidden for so long? The answer lies in the character of the era. It was a time when a sense of national duty was paramount, when the gravity of the oath they took was etched into their souls. Their silence was not born of fear alone, but of a profound, shared conviction that they were protecting their country. The true story was finally stitched together through the dogged research of historians who spent years digging through the newly opened archives and, most importantly, tracking down the surviving waves. When these women, then in their 70s and 80s, were finally told that they were released from their oath, their stories came flooding out. In interviews, their voices, frail with age, would fill with the pride and energy of their youth as they spoke of the mysterious Building 26. They recalled the immense pride they felt, the palpable sense of contributing to something vital, even if they never knew the full picture. They spoke of the camaraderie born of a shared, silent secret, a bond that connected them for the rest of their lives. Today, only one American bomb survives. Painstakingly reconstructed over years, using salvaged parts and original blueprints that somehow escaped the furnaces, it stands on display at the National Cryptologic Museum in Maryland. It is a hulking, magnificent relic, a lone monolith saved from the mandated purge. It whirs and clicks once more, not to hunt U-boats in the cold Atlantic, but as a testament to a forgotten genius, Joseph Desch, and to the secret army of women who helped him build it, operate it, and then protect its secrets for half a century, winning not only the war, but the silent peace that followed. The story of Joseph Desch proves that one brilliant mind can change the world. But does it also suggest that our greatest victories will always remain hidden from us? Let me know your thoughts below. And don't forget to like and subscribe for more incredible hidden histories.